Hello, I welcome you all. The problem reads, the assembly consists of two blocks A and B, which have a mass of 20 kg and 30 kg respectively. Determine the speed of each block when B descends 1.5 meters. The blocks are released from rest. Neglect the mass of the pulleys and the cord. This problem is coming from the Engineering Mechanics and Dynamics of 14th edition by R.C. Hibbeler. So we are being asked here to determine the speed of each block A and B, when B descends 5 meters. Right, descending meaning going down, right? So let's draw the free body diagram. We'll need the datum. This is going to be our datum and this one it will be there like so. So I'll have two datums. So B descends down, let's say by 1.5. So this will be how far it will go down, and when this happens it means A will ascend, right? A is going to ascend. A is going to ascend. Let me say I put it somewhere there because I'll still need some space for additional work. This one is going to go up. Right, so let me just clean it up, maybe up to somewhere there like so. I do the same that side. So with this information, let me again draw another datum for the kinematics to relate the displacements as well as the velocity. All right, so I'll cut it there like so, and then let me say from this point here, maybe it will be from there to there, and then this one from there to there like so. So let's say I have this going down is my reference, and the same is I have this one here, and then going down is my reference like so. All right, so don't get confused. This datum I want to use it for defining defining the potential, gravitational potential energy. So I'll call this as HB. Okay, then I'll call this as my HA. Okay, and this one is just equal to delta B, which is just equal to 1.5. Okay, this is 1.5. So let's call this one as we call this one as SB. Okay, then we call this one as SA. Okay, all right, so this is about it. Let's begin to work now. So SA, how many SAs? Sorry, we have 3 of them. So 3 SA plus SB is equal to L. Therefore 3 delta A plus delta B is just equal to 0. Okay, and delta A is just equal to minus delta B over 3, which is just equal to minus 1.5 over 3, and this is just equal to minus 0.5. Therefore, we do have delta B equal to 1.5 going down like so, and we have delta B equal to 0.5 and going up. All right, so this we've established. And then about the velocity, we know that 3VA plus VB, this is velocity. So 3VA plus VB is just equal to 0, right? So we know how they are related. So VA is just equal to minus VB divided by 3. So if we are to write this, we can say VB is going down while VA, which is equal to VB divided by 3, is going up. So that is how we can relate it. Okay, so with this information, it should be enough for us to begin doing the work. So we are going to use, since here we are dealing with conservative forces, we can straight away use the principle of conservative energy. And here we are just dealing with gravitational potential energy and some kinetic energy, right? So same, let's pick one point. So let's call this point here as point 1, and we call this one point 2. Okay, so we'll say T1 plus B1 is just equal to T2 plus B2. What is T? T is the kinetic energy, and V is gravitational potential energy and elastic potential energy. So what is T in our system here? Of course, they are all coming from rest, therefore this is just equal to 0. What about V1G? V1G, again, these are coming from rest. They are at 1. They are all in the rest mode. V1E, this is just equal to 0. We don't have any spring there, hence no elastic potential energy. Then T2, we are going to have that. So we'll have half mv. This is the kinetic energy. M, we'll say this is VB squared. We also have another one. This is half mVA squared. Then V2G, of course, they will have moved to point, and they will have moved to point 2. Okay, so this point is 1, then 2 is there, like so. Okay, so they'll have moved to points 2. Therefore, we are going to have for B, the datum is up, going down, therefore this is negative. So we say WB times HB. And then for A, datum is down, it's going up, therefore positive. So we say plus WA HA. Then V2E, this one is also equal to 0. We don't have anything, right? Great. So let's replace everything in one equation. I'll leave out those with zeros, just zeros. So we have 1 over 2 mvb squared plus 1 over 2 sorry, of course I need to start with 0 everything this side, and then I'll have half mvb squared, okay, plus, this is always positive kinetic energy, okay. Then we do have minus WB HB plus WA HA. Okay, so let's add numbers to that. So we have half so we know that HA, we said HB, we start with HB is equal to delta B, and is equal to 1.5 Okay, and therefore HA is equal to delta A, which is just equal to delta B divided by 3, and this is equal to 0.5, remember? And then VB, okay, VB, VA is just equal to VB divided by 3. Is that okay? So now let's plug in this equation. Let's plug it in. Let's plug these numbers in our equation so that we finalize our equation. What we have, we said 0 is equal to half. What is our M? So we have two M's, B and A. B is 30 kg. Then we have BB squared plus half 20 kg VA squared. Then minus WB is just 30 by 9.81 times HB, which is just a 1.5. Okay. Then plus WA, which is just 20 by 9.81, then times 0.5. Okay. Is that okay? Of course. It is fine, right? That term down, that term up, okay. So let's work it out. So we can replace VA like we said. Let's replace A. We're going to replace A with VB. So it will be VB divided by 3 like so, right? Then we say minus. There, that was a minus. Alright, so let's find what VB is, which you can do. Let's find VB. So I'll say, I'll take the others this side. So I'll say 30 times 9.81 times 1.5 and minus 20 by 9.81 times 0.5 and divided by 0.5 by 30 plus 0.5 by 20 by 1 divided by 9, right? Close brackets, then square root of that, and I have a 4.62, and this is in meters per second. Let me check it once more again. 30 by 9.81 by 0.5, and then minus 20 by 9.81 by 0.5 divided by 0.5 by 13 plus 0.5 by 20 by 1 over 9 and square root of that. Alright, and then VA we said is just equal to VB over 3, and therefore this is just equal to 4.62 divided by 3. This gives us a 1.54. Alright, so VB is going down and VA is going up, right? And I forgot also to show that we do have the weights here. We have the weight, we have WB like so there, and we also have WA. This is our WB, and this one is our WA. Okay, I guess this is about it. Let me just outline this. I guess this is about it. We have calculated VB as well as VA using the principle of conservation of energy. So I hope this video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and see you in my next screencast. I can also show here that our velocity here is going up, it's going down, sorry, this one is going down and this one is going up, right? So this one here is our VB and this one here is our VA. All right, bye bye.